Ever since Marconi demonstrated the feasibility of radio communications, researchers and scientists have endeavored to demonstrate the feasibility of telepresence. This, of course, led revolutionary advances in the field of telecommunications and also in social networking. So what I would like to do here is really to demonstrate the benefits of social networking and bridging the divide between social and wireless communications networking. In recent years, mobile communications has totally changed our daily lives. It changed the way we do business, it changed the way we live and communicate with the family, with friends and professional colleagues. This leads to the concept of social groups. The creation of social groups can be centered around a huge variety of different interests. Amongst others, for example, music lovers might like to share MP3 files, or they might like to exchange pictures of rock concerts or jam sessions, etc. It's also feasible that, for example, at the event of unveiling the identity of the new Pope, people who were closer to the podium were able to take better pictures and they would be able to communicate it right across the community. Or in fact, it could be related to very interesting scenarios in sports where people in a different stadium would like to see a goal in another stadium, or in the Olympic Games, events taking place in one stadium might interest people in another stadium, etc. So I would like to talk about the history, perhaps to start with, just casting my mind back to 1934, when the first social networking experiments were conducted. Although in the pre-computer era, the developments were relatively slow. It wasn't until 1969 when two scientists conducted the very famous 6 degrees of separation experiment. Now, in this experiment, the scientists gave very clear directions to a person who they were first in terms with, and this person was asked to send on a letter to a destination where the address and the name of the destination was clear, and they found repeatedly that in 5 or 6 consecutive hops they were able to reach literally everybody across the globe. Now this is of course the example of a rather large-scale social network, but there are also much smaller scale social networks, and so today I will try and endeavor to talk a little bit about the contrast between these two types of social networks. So let me commence with the cellular and large-scale opportunistic network hybrid. In the center, we see that a base station is transmitting to a number of smartphones in its vicinity, but the rest of these smartphones may be roaming in a distant rural area, for example, and they are therefore out of scope. So what happens is, once some of these mobiles receive the message of common interest, they roam further on in the terrain, and when they encounter another smartphone in their vicinity, they are able to pass on the message, and so on. So as it becomes quite clear, there's no base station involvement in the right hand side. So what I would like to do next is perhaps show you first of all a little demo, and this will highlight the way the social networks operate and improve the capacity of existing telecommunications networks. So on the left hand side, we have an integrated cellular and opportunistic network operating in a rural area whereas on the right hand side we have a conventional cellular network, again trying to cover a large rural area. There's a base station in the center in both scenarios, and the file size of common interest is 40 megabytes. The transmission rate is 1 megabit per second. The color coding is as plausible as possible, so let me commence by highlighting the red dot here, which represents a mobile user that has been unserved so far. And so in this left-hand side illustration, in fact, you can see that the majority of the nodes are still red. They have not received the information of common interest. Then there's the cyan mobile users, which have an incomplete file, and that occurs when they don't spend long enough in the vicinity of a legitimate transmitter. For example, here in the center we can see that the cyan colored dot just turned dark blue, and the reason is because it has succeeded in downloading the file, and therefore it has become an information owner, as seen here at the bottom. There is also a red dot, a green dot, which indicates an active information owner. For example, here at the top right and top left hand corner, that passed on the information. And then finally, I'd like to perhaps exemplify here the cyan turning red again, because it hasn't spent long enough in the vicinity of this dark blue dot. In other words, the chance encounter hasn't been sufficiently long in order to pass on the data file. Same happened here as well. So I'd like to perhaps fast forward now a little bit, almost to the end of the demo, but of course you can watch this at your own leisure. And if I fast forward to the end, you see that the mobility model is sped up, and when we get to the end of the demo, then it becomes clear that in the integrated scenario, 92.5% of the nodes have received the information of common interest. There's only a couple of red dots here, whereas on the right hand side, only a much smaller fraction of the nodes was capable of receiving the information. So just to take you through once more at a very low pace, the color coding scheme was again cyan represented a partially received file, and therefore it was discarded. The dark blue represented the silent information owners who have already received the information but are not transmitting at this stage, and the green dot corresponded to an active information owner, as exemplified here at the top left-hand corner, for example. On the right-hand side, within the same duration of 1272 seconds, only a much smaller fraction of 10% of the users was capable of downloading the file of common interest. And if I can just take you through again to the end of the demo at 1 hour or 3600 seconds, then it's very clear that the hybrid dissemination system vastly outperformed the conventional base station aided system. Now, of course, there's many reasons for this, and these reasons are discussed throughout the paper itself. But let me now move on to contrasting the large-scale network to a small-scale opportunistic network. Suffice to say that the most important difference between them is that in case of a densely populated area where many mobile stations are in each other's vicinity, we have to carefully control the interference, which was not the case in the large-scale scenario. I will not delve into discussing the specific details of the frame structure. Suffice to say that there is a base station aided multicasting, and so in the second stage, for example, mobile user A receives the information of common interest, and it will send it on. It will broadcast or multicast it to the other mobile stations, and then as the information dissemination proceeds, more and more mobile stations receive the desired information, so a large amount of teletraffic can be offloaded from the conventional cellular network to the social network. There's many different ways of implementing this. One possible option to consider is that we actually have access to more spectrum, for example in the Wi-Fi band, or alternatively in the millimeter wave band in the downlink. It's also possible to use visible light communications, etc. This small-scale scenario has a slightly different color coding scheme, so I'd like to take you through the color scheme first of all. We've got the red dots, which indicate the unserved mobile users that are not in the target interest group. Then there's the magenta colored hitherto unserved mobile users that are in the target group. So our goal will be basically turning these magenta colored dots into cyan colored dots, so that the information owners in the target group all finally receive the information sought. And the dark blue dots indicate the information owners not in the target group. The green dot finally represents the information multicasters, and the black triangle is the base station. So that's the first stage. It's important to note that the hybrid dissemination scheme will use a base station transmit power of 12 dBm and a portable station power of 4 dBm. So the coverage area of the portable stations is definitely much smaller than that of the base stations. And at the right hand side, as well as in the middle, we have two classic base station aided multicast scenarios. The difference is that in the middle we have a 23 dBm transmit power, which is 11 dBs higher than the hybrid dissemination scheme's power, and at the right hand side we have exactly the same base station transmit power as at the left hand side, so we can make interesting comparisons on this basis. I'd like to mention also that the blue line indicates the presence of a wireless link, whereas the green line is a successful delivery link. So in these snapshots, at the left hand side we can see 1, 2, 3, 4 different green links, but the coverage area of these is somewhat lower than in the middle, because again the power is 11 dBs lower, and so the scenario in the center is capable of bridging larger distances, and so potentially disseminating the information to more information seekers. So that's the first stage, and just to really take a little step back again and remind ourselves of the second stage. So the second stage is where the mobile stations multicast the information, and we go through some of those stages. So looking at the second stage now, without going through the color scheme again, we observe that at the left hand side in the hybrid scenario there is 1, 2, 3 and essentially these arrows indicate the successful reception of the information of common interest, and we can also see that there are 3 cyan colored dots indicating the information owners in the target group. And in the middle we have actually 4 information owners in the target group, and the 4 red arrows indicate the successful reception during this particular snapshot. And at the right hand side we have again the same base station power as the base station power of the hybrid dissemination scheme was, and in this scenario we can observe 5 successful links, and there are 4 cyan-colored dots indicating the information known as in the target group. What is worth mentioning at this stage is that the energy dissipation in the left is 48.5 milliwatt times the time slot duration, and at the right hand side in the base station aided scenario it's very similar, whilst in the middle it's actually 598.6 milliwatts times the time slot duration. And so these performance metrics are worth watching when we finally look at the moving demo as well. So I'd like to just start up the demo, and this is quite intriguing. So at this stage we can see that it's the base station in the center that will be transmitting, and the color coding scheme indicates that at the left we only have one information owner in the target group. In the middle, because the base station transmits at 11 dB higher power, we've got actually 3 successful information owners. And at the right hand side, again owing to the random nature of the simulations, we have 3 cyan colored dots. So actually at this stage it seems like the classic base station aided multicasting is winning. But it's not all as simple as that. So I start the simulations again, and let's see how it actually evolves. Down here at the bottom we can observe as the number of time slots increases, and at this stage I just stop for a moment and observe that this current information multicaster succeeds in multicasting the information to this particular mobile, and therefore that turns dark blue, but it becomes an information owner that is not actually in the target group. In other words, likely to have different interests from those 5 mobiles that are in the target group. So moving on again, it's kind of interesting as the simulations evolve, and at this stage I will probably fast forward a little bit, and then I will stop the simulation so that we can compare what is going on. So at the left we have now 5 cyan colored mobile stations, which indicates that the target group actually has succeeded in acquiring the information sought. And in the middle the same is true, whereas at the right hand side there's only 4 cyan colored mobiles. So the classic base station aided scenario was less successful than the hybrid dissemination scheme. At this stage, perhaps let's just also look at the performance metrics very briefly. So the energy dissipation by the hybrid dissemination scheme was 116 milliwatt times the time slot duration. As far as the lower power but identical power base station is concerned, it's 110.9 milliwatts times the time slot duration, whereas in the center the higher power base station has already dissipated nearly 1000 milliwatts or a watt times the time slot duration. Another important performance metric also treated in the paper is actually the dissemination delay, which at the left hand side was 5 frames. For the classic base station scenario was also 5 frames, but again don't forget the power is nearly 10 times as high, or in fact 11 dBs higher. And at the right hand side the dissemination delay is 6 frames. So let's just run through to the end and then perhaps stop there for a minute just to envisage the overall performance. So up to this stage we are now at 116.3 milliwatts times the time slot duration, and the base station aided classic scenario is again around 1000 milliwatts times the time slot duration, and at the right hand side the lower power base station dissipated 158.5 milliwatts times time slot, but the dissemination delay was 10 frames. So my hope is that you have enjoyed the demo, and I'd like to entice you into visiting the demo at your own pace, experiment with it, and I promise you that this will substantially augment your inclination to read the paper as well.